All right, 6.2a differentials, growth and decay. The first thing we're going to do is solve by separation of variables. And I need a reader for our teal portion, and Gunner's going to read, I guess.
The strategy is to rewrite the equation so that each variable occurs on only one side of the equation.
All right, so we need to get our x's with dx's, and I need to get my y's with dy's. So we need to get dy's with y's and dx's with x's. The first thing is to separate our variables. Now, we're going to start doing some AP problems soon, and these problems are usually worth like 5 or 6 points out of the 9 on a free response question. And guess what happens if we can't separate variables correctly? Guess how many you get out of the 5 or 6? You get 0. No matter what you do from the rest on, if you don't separate your variables correctly, you get 0 out of that. All right?
Wait.
So this is kind of sloppy notation. What do we think of y prime as? dy dx. So I'm going to rewrite this as dy dx is equal to 2x over y.
Am I the only one who sees it?
So the first thing I want to do is I need to separate my variables.
I already see it.
So now I separate my variables. So what do we do with y? We multiply it. So now I have what on my left side? Y dy. And what do I need to do with dx? I need to put it on the right side. So now I have 2x dx. All right, so that's step 1 is to separate. Step 2 is we're actually going to integrate now. All right, so now we're going to integrate both sides. So what is my antiderivative of y with respect to y? Y squared over 2. All right. And technically it's plus c. However, I don't actually write a plus c over with my y's, and we'll talk about that in a second. What is my antiderivative of 2x dx? X squared. And then plus c. Now, the reason why we don't have plus c on both sides is if we were to combine our constants of integration, it's still going to be a what? A constant of integration. All right, so we usually just put it in with the x's. Does everybody make sense of that? All right, so now to find a general solution, it's either solve for y or solve for c, and I really don't care which one you do right now. So which one would it be easier to solve for? C. So c would equal what? Y squared over 2 minus x squared. And that's good for me right now. Pretty good? I want to talk about some notation that we might see. Sometimes they actually ask for dy dx, and they give you f prime of x. And we need to recognize that f prime of x would equal dy dx. All right?
Wait.
Another thing that I think is kind of dirty is sometimes they give it to you like that. It's a separate integrate problem. Because f prime is actually what? Dy dx. And then f of x is actually what? Y. All right? I kind of think that's rude. However, I've seen College Board do it a couple times. All right? All right, let's do this one now. So we're going to solve for y if I have dy dx is equal to the quantity of xy squared. And I have an initial condition y equals 1 and x equals 1. So here we go. I need to separate these out. But the first thing I want to do is what? What do I need to do with this squared? I need to distribute it. So now I need to think of it as x squared, y squared. And I don't like this notation. I would make it an ordered pair. So I'm going to call it 1, 1. So how would I separate these variables? Divide by what? Y squared and multiply by dx. So now I end up having dy over y squared is equal to x squared dx. All right. If we don't get that first step right, we're going to miss everything else. Okay. So now my first step was separate. My next step is integrate. So now we're going to integrate both sides. And we've done this left side a lot by now. Hopefully we can get it pretty quickly. What is my antiderivative of dy over y squared? Negative 1 over y. All right. Is equal to, what is my antiderivative of x squared? x cubed over 3, and then plus c. All right. So now when we actually have this thing called an initial condition, I want you to solve for c. That would be the third step. We're going to solve for c. This is where Larson and I disagree a little bit. He will not actually solve for c right here. Can you trust me? All right. I want you to solve for c. All right, so now we're going to substitute in. So now I have what on my left side?
-1.
-1 is equal to 1/3 plus c. So now we solve for c. So what do we want to think of -1 as? -3/3. So c equals what? -4/3. So now I solve for c. So now I want to back substitute. All right, so now we're going to take c and we're going to back substitute it in. Just like last night's homework, basically. All right, so even though you thought it was a little bit useless, which it kind of was, this is where it's going to come into play.
Wait, I think I've got it.
So now we have -1 over y is equal to x cubed over 3 minus 4/3.
But
So that's
since
step
there's a
4.
denominator, you can actually just do x.
Now my fifth step, which is the hardest step, is going to be solve for y. All right, so the last step is solve for y. And that's the hardest step usually. So I can go many ways to Tampa. Which way you want to go to solve for y? Multiply by y. That's fine. All right. I agree. I wouldn't do that either. However, we're going to go this way to Tampa for right now. So we're going to multiply by y. So now what do I have on the left side?
-1.
-1 is equal to. Now what do I do with it? Divide by that, right? And so now I have x cubed over 3 minus 4/3 is equal to y. Now, if it's a free response question, they will take that. They really will. However, if it's a multiple choice question, that will not be the answer. All right. What will they make you do? Multiply by 3/3. So then when we multiply everything by 3/3, we end up with y equals -3 over x cubed minus 4. All right, they might have that. Now, I'm going to show you my way of doing it from here. They already have common denominators, so you kind of have this like -1 over y equals this x cubed minus 4 all over 3. However, I have a negative going on, so I'm going to distribute the negative. That's what I personally would do. And then, guess what? We can flip everything. And so then I'd end up with y is equal to 3 over 4 minus x cubed. That's personally how I would do it. However, what's the wise man say? Many ways to Tampa. All right, pretty good in the hood? All right. All right, so now we're going to get to growth and decay models. We've actually done this last year in pre-calc, and we did it maybe a little bit in Algebra 2. I'm not sure. All right, I need a reader up in her, though. Hubin, I love your voice.
In many applications, the rate of change of a variable y is proportional to the value of y. If y is a function of time t, the proportion can be written as follows.
All right, fantastic. So in AB calculus, this is kind of nice. The only differential that we really need to be worried about is a thing called a proportional. So if you ever see the word proportional, we can skip down to dy dt equals ky, or a lot of the times we actually jump down to y equals ce to the kt. However, that has to be proportional, or the law of exponential growth. All right, and Aaliyah's going to read for us.
The rate of change of y is proportional to y. When t equals 0, y equals 2, and when t equals 2, y equals 4. What is the value of y when t equals 3?
All right, so it says proportional, so we can jump to y equals ce to the kt. All right, we can jump straight there. Now, instead of reading t equals 0, y equals 2, what would I highly recommend you doing? Make an ordered pair. So what ordered pair do I have? 0, 2. And then 2, 4. And then 3, question mark. I like to do those question marks. Remember doing this from last year at all? Maybe a little bit. All right. All right, so now I need to solve for c and I need to solve for k. Those are my constants in this proportional rate of change. So let's just substitute in. So now what's my y? So I have 2 is equal to ce to the k times 0. Well, what's 0 times k? 0. E to the power of 0? 1. So c equals what? 2. So now my equation would be y equals 2e to the kt. Now what do I have to solve for? I have to solve for k. So now I'm going to substitute in my next ordered pair. So now, what would I have? 4 is equal to 2e to the 2k. All right. Now what do we do?
We could divide by
Divide by 2, and then what? How do I get to k? Natural log it. So now I have natural log of 2 is equal to 2k. Now what do I do? Divide by 2. So k is equal to 1/2 natural log of 2, or natural log of 2 over 2. All right. So now what do I do with that? Substitute it back in. So now I end up with y is equal to 2e to the 1/2 natural log of 2 times t. Well, I'm almost there. What do I need to find? I need to solve for y when t is equal to 3. So I just substitute in 3. So y equals 2e to the 1/2 natural log of 2 times 3. All right, we end up with 5.6569. All right, pretty good in the hood. All right, so now we're going to talk about Chernobyl. All right, I need a reader, and Skipper's going to be my reader.
Suppose that 10 grams of the plutonium isotope was released into the Chernobyl nuclear accident. How long will it take the 10 grams to decay into 1 gram?
All right, here we go. So, I need to make these into ordered pairs. What are my ordered pairs that I can create here? Suppose at 10 grams. So what's my first ordered pair? 0, comma, 10. What else would be my ordered pair? Question mark, comma, 1. Exactly. I need to figure out what time it goes from 10 to 1. Now, this half-life thing is going to come into play. So I have a half-life of plutonium as 24,100. All right. It is a long time. All right. So that's what we have. So now we have y is equal to ce to the kt. And we're just going to start substituting in what we have. So what's my y? 10. So now I have 10 is equal to ce to the... Okay. So now what is c? C is 10. So now I end up having y is equal to 10e to the kt. Now we need to solve for k. And this is where we use our half-life going on. So every 24,100 years, it's halvesies. So if I start out with 10, what would be halvesy of that? That'd be 5. So now I have 5 is equal to 10e to the 24,100 k. That's how long it took. That's how much time it took. But what's my first step here? I divide by 10. And this is where I want to talk about some things right here. Does it matter how much we start with to use a half-life?
No.
It doesn't matter. All right? So I want you to actually recognize that, and I kind of want you to start jumping to this step right here. Does that make sense? It doesn't matter what we start with. We're going to get half because it's a half-life. So half is equal to e to that amount of time, k. You following me? So then what do? We natural log it, and then what? Divide by,
2, 4, 1, 0.
there it is. So k is equal to natural log of 0.5 over 24,100. All right. And I've actually had some students that jump there, and that's fine by me. All right. I usually try to have them jump there because I think it makes more sense. So then I end up having y equals 10 e to the k of natural log of 0.5 over 24,100 t. And what am I trying to solve for? T. I'm trying to solve for t when y equals 1. So now I'm going to substitute in 1 is equal to 10 e to the natural log of 0.5 over 24,100 t. So what's my first step? Divide by 10. And then what do we do? Natural log it. So now I have natural log of 1/10 or 0.1 is equal to this natural log of 0.5 over 24,100. Now, I've had some students in the past that like to multiply by 24,100, divide by natural log of 0.5, or they just take this and divide by that. All right, and I'm okay with either one of those. All right, so put in your calculator. So we end up getting 80,058 years-ish, all right, to go from 10 grams to 1 gram. So not much time, right? All right, I think I'll be dead by then. All right, so I'd like you to write these out, and then I want to do number 34 with you. Write these out, and then I want to do number 34. So on 34, very similar to what you guys did last year, we need to fill out this little chart. And in 34, they give you a half-life is 1599 years, and then it gives you an amount after 10,000 years, and it asks to solve for initial quantity and the amount after 10,000 years. So this is going to be solving for C for our initial quantity. And then I kind of like to think of these as ordered pairs. So this ordered pair would end up being 1,000, comma, 1.5. That's kind of what I think of it as. And then the amount after 10,000 years is this 10,000, comma, question mark. Okay? So we need to solve for initial quantity and the amount after 10,000. So I'm going to start with the initial quantity. But before we do that, we actually have to solve for what? If I have this equation, y equals c e to the kt, what do I need to solve for? I need to solve for k. All right? And k is our half-life kind of going on there. All right? So I need to think of it that way. So just like what we talked about in our last problem, what do I want you to jump to? 1/2 is equal to e to the 1599k. All right? So then we do what to it? We natural log it, and then what? Divide by 1599. So k is equal to the natural log of 0.5 over 1599. All right? Whatever that number is. I truly don't want you to put it in your calculator yet. The reason being is if you did your calculator, you round right there. And then if you get your real answer, what's going to happen again? You're going to round again. You're rounding how many times then? Twice, and I don't want that. So now we end up having y is equal to CE to the natural log of 0.5 over 1599t. Now I need to take what I have. So I have this ordered pair 1,000, 1.5. So that's what I'm going to substitute in. So what's my y value? 1.5 is equal to CE to the natural log of 0.5 over 1599 times 1,000. All right. And so what's C in that E's relationship? They're being what? They're being multiplied. So guess what I need to do? I need to divide. So C is equal to this 1.5 over e to the natural log of 0.5 over 1599 times 1,000. So now 2.3139. Fantastic. Now, it actually goes further than that, does it not? Yes? All right, it goes further than that in your calculator. Yes. So, when we find the amount after 10,000 years, you have this number in your calculator already. You following me? So now we end up having y is equal to c, whatever you have in your calculator, and then you're going to multiply it with e to the point, or natural log of 0.5 over 1599 times what now? What's my t? 10,000. So I'm going to keep all of them, and then you just press times, and then the e to the natural log. 0.0303 grams. All right. All right. Get working.